Oh, this is actually my computer is always mega slow when Java projects are loading. Day 16. I'm gonna play with something here. Let's see if this is available for... Oh, nice. So I could just use the public link, I guess. Oh. Bo. Ah, I'll figure it out later. Okay. It is almost that time. Oh, we're on 16. Just to let you know, I'm not one of those super fast guys. I think my fastest one was like 45 minutes for this year. I'm kind of slow. Alright, let's see what we have. Reindeer Olympics. The Reindeer Maze. Oh, cool. Where the reindeer compete for the lowest score. You and the historians arrive to search for the chief right as the event is about to start. It wouldn't hurt to watch a little, right? The reindeer start on the start tile, marked with an S, facing east, and need to reach the end tile marked E. They can move forward one tile at a time. They can move forward one tile at a time, increasing their score by 1 point. Okay. But never into a wall. They can also rotate clockwise or counterclockwise 90 degrees at a time, increasing their score by 1,000 points. Okay, so it's 1,000 points per turn. To figure out the best place to sit, you start by grabbing a map, your puzzle input, from the nearby kiosk. There are many paths through this maze, but taking any of the best paths would incur a score of only 70-36. This can be achieved by taking a total of 36 steps forward and turning 90 degrees a total of 7 times. Here's a second example. In this maze, the best paths cost this much. Following one such path would look like this. Okay. Notice that the path shown above includes 190-degree turn as the very first move, rotating the reindeer from facing east to facing north. Analyze your map carefully. What is the lowest score a reindeer could possibly get? I already know part 2 is going to get crazy, but I'm going to go for a DFS and just get the minimum score out of a DFS. Probably do like some dynamic programming too. I know it's going to bite me in the butt. Okay. So to get our input in there, I'll use the second example. Let's use the bigger one. Okay. Let's close this stuff. Yeah, we're just kind of slow. Let's do a little before each here. We got our sample input. Okay. And we're going to have a day. This language server needs to pick up the pace because I'm a slow typer. And we're going to have an expected. I'm going to go with a long. I feel like these are going to get crazy big. Expected equals that. The actual is going to be day part 1. Okay, let's go ahead and put that in a file too. Okie dokie. Okay, first thing we're gonna do is make a grid. And we'll just do a character grid. Yeah. We're gonna have some this many columns, this many rows, or that many rows, that many columns. Parsers. In is a number of columns, and we are going to return cheapest path, and I'm going to do this with just a recursive DFS. Cheapest path. Yeah. And if we have reached, I'm assuming it's always possible to finish. Yeah, it's a maze, right? It's gotta be possible to complete it. If we've reached the end, now why don't we pass some coordinates here? And let's also find the start point. I'll do it. Find the start. If grid ij equals s, return that position. So the first thing we want to do is find the start point. Okay, and if grid ij equals, what's the end? E, then we want to return, let's keep track of a cost here too. Return cost. Okay. Otherwise, we just want to go through all the 4 directions. Yeah, 4 directions. Up, or we're going to go up, down, left, right. Up, down, left, right. Up, down, left, right. For each one of those directions. For each direction, we're going to travel each direction, and then we're just going to return the min. Cheapest path. I'll say lowest score. I'm just concerned about the cost of it, yeah. Equals 0. Is that music loud? I'm actually going to turn the music off. For each direction, we're going to say lowest score equals... Oh, actually I need to do a big old number right here. Long.max value. Math.min. Cheapest path. I plus DID J plus DI or DJ D. And the cost is gonna be, oh yeah, only if we've turned, right? So why don't I pass a direction here too? I'll say CD for current direction. The cost of this next move is if D is equal to the current direction, that cost is going to be, well, it would be, is it just 1? Yeah, 1.1. Else it's going to be 1,000. Oh wait, we can only turn 90 degrees. We should only go so it's not quite going to be that. What? Well, what is the... So if we have to, well, we can't go backwards, right? Okay. So So I'm actually not looping through all 4 directions. I can only go straight left or right. So that's just going to be straight is going to be going the cheapest path. I plus DI. I'll say direction. J plus DJD. Same direction. And I gotta think about how to actually order these. So up. I should do up, right, down, left, up, right, down, left. That way I can like cycle through them. And going straight would look like this. Cost plus 1. Visited. So we'll put visited. I should put visited up here. Visited dot add new pair IJ. Pass that visited. So that's going straight. Or we could go left or right. And going left would look like I made sure I go. Wait. Yeah, I can rotate clockwise or counterclockwise. So my numbers are ordered in clockwise, right? Up, right, down, left. Okay, so going left would be subtracting 1. D minus 1. And that's mod 4. It's a cycle through them. That's definitely a better way to do that. And if I'm turning, it's plus 1,000. Plus, right? Plus 1,000. If I turn, it's plus 1,000. And then right the opposite here. Taking a right would be adding 1 to the direction. Plus 1,000. And then I just want to return the min. Math.min between straight, left, and right. And I should definitely do some dynamic programming here. Oh, that's right. Straight, left, right. Okay. Let's see how slow it is without dynamic programming. did it not import it for me? You son of a gun. Also don't have tests above this. I'll leave that one blank for now. Alright. We failed it. We knew we would. I knew I would. Let's add this legit input file. 16. And let's run it with that sample. -1. What? Oh, wait. We're also not checking if it's if grid. Oh yeah, do that after we mark it as visited. Actually, add visited after we check. Oh, and also you want to you don't want to advance if it's already been visited. If grid ij equals a wall, then return long.max. Visited add. Is there a better way to do this? Yeah. Oh, yeah, we don't want to use I though. Let's use what should I use? What should I call it? I don't know. I really don't know. And oh yeah, you need to do plus 4 mod 4. That's the next direction. And lowest score equals math.min. Cheapest path I plus di j plus dj, next direction. And yeah, next direction. Cost plus is next direction equal to our original direction. Then it's going to be 1, else we're making a turn at 1,000 and then pass the visited. What? Oh. And then you just want to return lowest score. And you should also well, is it always surrounded by walls? Is there always a wall? Yeah. So I don't need to worry about going out of frame or anything. Got that. Infinite recursion. Oh yeah. If it's already been visited. Can I do that here? I should do that down in the loop, I think. Not quite, huh? It's 1 for going straight. And 1,000 for turning 90 degrees. Wait, how much am I off by? A good amount. War? Oh. Well, that's... Well, yeah, the cost does start at 0. Oh, you know what? You shouldn't do this. Well, I don't think it matters. I don't think it does, but next. And what? What do I get for the other sample? I'll call this sample 2. I'm supposed to get that number. No. Okay, something's wrong here. So you only want to move. Oh, you know what? We're probably. Up, right, down, left. And the next direction why don't I start at 0, 1? Oh wait. Wait, I think I'm doing this wrong. Let's see what path I'm taking. There's no telling which one I'm reaching it with. Oh. Do it right there. How did that happen? Oh, we just like went around like that. Whoa, why did we only hit it twice? Oh wait. Hmm? Okay, well that's a problem. I think it has something to do with my visited. Why isn't that working? What the hell? Am I missing something here? No. I'm just coding it wrong. So we're only finding... What the heck? Oh, you know what? I can't do a DFS. I need to do like A star or something. Okay. 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 Let's do Dijkstra's. I think I've done A star before. It's kind of a pain in the butt. Okay. We'll do Dijkstra's. Yeah, not a DFS. What was I thinking? Okay. So let's like redo this. See what I need here. I think I'm still going to call it cheapest path. And the score, I want the score for that path, right? What? So you take in a graph and a source. I could build a graph. That would be cool. A cool utility to have, actually. That would make this a lot cleaner. And with that, I would do a DFS. Could. How much time do I want to spend on this? I might do that. What if I just did it with coordinates? You could. Where's the other one? What's the difference between these? Well, it's not only is it a shortest path. Not only is it the shortest path. Because the cost of your next move depends on what direction you went. Tricky. I feel like you could do Dijkstra somehow, though. Well, yeah, I'll just apply the distance. Wait. Distance to source is 0. Q.add source 0. And then for each vertex in the graph, if that vertex is not the source, then previous vertex is undefined, and the distance to that vertex is infinity. It's unknown. And then add that vertex with its distance. And then while the queue is not empty, okay, so use a priority queue. Yeah, this is a priority queue. What is the other one? I'll do this one. So I'll take a graph. For each vertex in the graph, make the distance to that vertex infinity. And the previous vertex undefined, and then add that vertex to the queue. What's up with that? Why is there like no indentation? Distance to source is 0. So the distance to source is 0. I think this is after the while loop, right? I'm assuming. Distance to source is 0. While Q is not empty, U is the vertex in Q with the minimum distance to U. Vertex in Q, minimum distance to U, right? Remove. Oh, where's vertex distance? Oh, it's just gonna be the source. Pop it, and then for each neighbor. For each neighbor V of U, still in Q, that is still in the queue. Alt is the distance to U plus graph.edges. Huh? Dang, this pseudocode's kind of confusing. Extract them in for each neighbor V of U. Distance to U plus alt. Distance to U. What does that mean? The distance to U plus graph.edges UV. Oh, that's like the length of the edge? Yeah. Right? Graph out edges. I guess so. Distance to U plus if alt is less than distance to V. Dude, why is there no indentation? This really screws me up. Distance to U plus if alt is less than V. It's less than for each neighbor V of U still in Q alt distance to U plus, okay, the actual distance right there. If that's less than the previously recorded distance to V, then that distance to V equals alt, and then the previous vertex to V is now U, and then add V to Q with the distance alt. Okay. Okay. While not empty. Yeah, I think all of this is supposed to be inside of this while loop. It's mad confusing because there's no indentation. And then return the distance array, and then this would be like the actual path. Let's try it like that. So we're gonna take this is previous. Why don't we just keep those up here? So those will be maps. We're gonna map prev is mapping pairs to pairs. And distance is mapping a pair to a long. Okay. And I guess we'll just like find cheapest path from We have our grid. We're just going to use the grid, I guess. And first, just go through the whole. Go through the grid. I guess. Yeah, they're vertices. Oh, that's why my computer's acting all slow. I have a shitty battery, so when it gets slow, things get weird. Grid IJ is over there. Yeah, if it's equal to wait, what the heck are we doing right now? I don't think this is gonna work actually. Yeah, just say if it's... Wait. Oh, we're just worried about the distance then, right? Yeah. If it's not equal to a wall, then... dot put... Let's do this. Put v with long dot max value, and prev v is null, which it already is, and then add v to q. Wait, where the heck is the q? Doesn't need to be a priority queue. Q, right? Q. There's new linked list. No. And it's gonna be a queue of pairs. Add that sucker in there. Huh? Q dot add v. Okay. And then we say, what in the world is going on here? We're like a slightly off. Okay. And we say distance dot put source 0. Excellent. Okay. And then while not queue is empty, use a vertex here at the minimum distance to U. Gosh. With the, I should use a priority queue here. Yeah, let's use a priority queue. Priority queue, and I need to pass like comparator to this, right? Use the vertex and queue with minimum distance to U. Yeah, with the minimum distance. So I should sort it by how do you new comparator. New comparator. And what are we comparing here? We're comparing pairs, right? We should get well, they all have a distance, right? Yeah, they do. Distance.get oh. I don't think I need to do that. Yeah, okay, whatever. I guess it needs to be an int, huh? Return distance.get v1 dot compare to distance.get v2. Is that okay? Oh yeah. Wait. Oh, okay. Maybe? Maybe. And then while queue's not empty, pair u equals q dot poll, and then for each neighbor of v that is still in queue. Okay, each neighbor of v that's in the queue. Up, down, left, right. Each neighbor v equals new pair, and this is going to be u dot get a plus did u dot get b plus djd. And if q dot contains v, we get the alt distance is going to be distance.get u plus that actual distance. Crap. Ugh. Ugh. Wait, I knew this probably wouldn't work. I think we might need to do... Dang it. Yeah, I guess the turning... It's the turns that really dictate the cost. Oh no, man. I really think that last one should have worked. Why wouldn't a DFS work? I gotta think about this one. Given some names and there's 12s, let's say easier. S is here. You know, there's a couple of paths. Then you can go you should be able to DFS. Oh, yeah, if you're visited. If you visited it, you should return long.max value. Yeah, if you've already visited it, you should return long.max value, I think. I'm going to go back to my previous solution. Oh, because I don't think ASAR or Dijkstra's is going to work. So we're going to back way up, put it reverse Terry. Put it in reverse Terry. I just don't think it's going to work with that kind of pathfinding algorithm. Let's put that back in there. So if we, I wonder how the volume is like that without my headphones on. Check, check, check. It's still pretty good, right? The volume level's still pretty good. So I'm gonna do it like this. If we're at the end, you know, return the costs that we accumulated. If we are at a wall, or we have visited this spot, dot contains new pair ij, then return long.max value. Otherwise, add this thing to visited. Start start 0. Start 1. The first direction will do 0. The initial cost is 0. Get rid of this. New hash set. Same answer we were getting earlier. Why are we getting that answer? So we're only finding 3 paths. Weird. Why are we only finding 3 paths? That's a good question. I mean, there's obviously more than 3 paths. There's a ton of them. Yeah. Oh. I think I need to do A star, dude. You know what? Don't have the visited. What if I don't have the visited? Because I do want to revisit. I do want to revisit spots, so this might not work either. I think this will give us a freaking Stack Overflow. Will this not give us Stack Overflow? I'm pretty sure it will. Yeah, dude. What if I like pop it back off? What if I keep like a path going? Add it to visited. Continue. And if it's like not lower. Yeah, dude, I need to do like a pathfinding thing, man. Pretty sure. But I can keep this hash set. I can keep this a set. I'm pretty sure I could do that. So I'll grab that first. And we'll do this. I don't know if this is going to work. Say long cost equals this, and if cost, oh yeah, do that. Visited dot add new pair I plus DIDD J plus DJ DD. Get that cost, well, call something else for a second. And if score is less than lowest score, actually if it's greater than or equal to lowest score, then you say visited dot remove I don't think that's gonna work either. Oh my gosh. Just spitballing right now. How did we get that? How in the heck did that happen? Where? Line 46. Huh? How did we get a -1? Now how did we end up with -1 for real? Oh, this is supposed to be new direction. Freaking goofball. Would A star work? Let's look at A star real quick. We want the funk. Now, why did I think this wouldn't work? I think this would have worked. No, because we need to know the direction. Oh, but I had the direction, right? Oh, breach neighbor. Oh. Oh, wait, no. Breach neighbor. Yeah, because we need to know like the previous direction. That makes it so tricky. What is A star like again? Ah, boy, oh boy. Yeah, I have done this one a couple of times in the past. Okay. So would this work for us here? Gosh, what's with all the comments, dude? Open set came from... See, this could help. I think A star is what you want to do, actually. G score is a map with the default value of infinity. G score start 0. F score is a map of the default value of infinity. F scores start is the heuristic to start. While open set not empty. Current is the node in open set having the lowest F score. The lowest F score. Yeah. Okay. If current equals goal, return reconstruct path came from current. Came from current. Came from current. Oh, okay. Came from just like a map. Open set dot remove current. Yeah, otherwise open set dot remove current. And then for each neighbor of current, tentative G score is G score current plus, what is D? Okay, for each neighbor. See, for this you need to know the previous freaking direction. Oh, I guess you could do that with current. Came from. You could get came from current. Oh, okay. Came from. Came from. Where does came from get used? Where the heck does came from get used? What the heck? For node n, came from n is the node immediately preceding it. Okay. Okay. Well, when are you adding those? I don't see you adding them. Oh, right there. Okay, so I could... Right here, when I'm saying for each neighbor of current, I can get that direction by doing came from current. So then I could know the cost of moving to the neighbor. Yep, I need to do A star. Sick. I really hope that once I implement A star, I really hope it just works for part 2, man. Okay. I think we're doing A star. Took me only an hour and a half to figure that out. Okay, so it says book up and for each neighbor of current, you can get the cost. The cost is either going to be, well, so you want to get the direction. Yeah, you want to get the inverse direction towards your previous guy. And if the direction to your neighbor is the same as that, the cost is 1. Ugh. Otherwise, it's 1,000. Current. Each neighbor of current. Now, wouldn't one of its neighbors be the came from? Neighbor of current. I think so. While current came from keys. This is reconstruct. Start. The heuristic's going to be way off. Well, I want to watch some people do it real quick because I'm not 100% actually. Oh man, I don't have any of it done. Dang. Dang. This guy did it in 15 minutes. I'm way overthinking it probably.
Alright, day 16. What's going on? We got a grid. The east is a point. Clockwise, 1,000 points.
Wait.
We see a tile for the west. Okay, sounds.
Wait. What? Hold on. Did I not read something in the... I think I didn't read something in the instructions. Facing east. Oh my gosh. So we start facing east. Well, that doesn't really change anything. Well, it does kind of change the cost.
it's more counterclockwise. Empty. Up, right, down, left.
Yeah, that's what I was thinking. You cycle through them. Alright, let's see what the heck he did, because it was not a lot of code. So, let's see here. So he's finding the start and the end. He has a Q. Key push. C. And he's putting, what is he putting in there? He's putting, something. What is that? That must be the direction. Left. Wait, what the heck? Oh, no, it's down. That's up. So he starts right. That's the direction then. That's the cost. So cost 0, the position, and the direction. Yeah. Right? And then while the queue's not empty, he's getting the... Oh no, that's direction. No? What is that? That's the cost. D is usually cost. So cost, position, direction, popping it from the queue. If we're at the end, break. If row, column, and direction, if the position and direction has already been seen, continue. Else, add it to scene, add the position and direction to visited, and what is that? Deers. What is that? Deers. What is deers? Oh no, okay. It's getting the direction offset. Then he's getting the next cell, and then he's seeing if what is big C? Okay. If we're not out of range and it's not a wall, then put that thing in the queue. Wait. If we're not out of range, and it's not a wall, put it in the queue with cost of 1. Why would he? Row column. Why is he doing that? Oh, you don't move, you just rotate. You're not moving, you're rotating. That's where I was screwing it up. That's where I was screwing it up. Oh, I think my solution would probably work out. I'm screwing it up because I was moving. But you're supposed to just rotate or move forward. Crap. I don't think I'm too far off then. But visited needs to be... What does visited need to be? Position. Direction. And why would you use a Q? What kind of a solution is that? Can I do it? Let's try it like how I was doing it. Let's just let's take this out here. Yeah. Let's just put that up here. And we're going to record position. And direction. We'll just do it as an integer. What? What are you bitching at? Oh, yeah, that's right. I need to do it as a pair with a pair in there. Position, direction. Position, direction. Okay. And I have my directions cyclable right now. Yeah. Up, right, down, left. And we're starting facing to the right. So, don't need that. We're gonna start facing east like it said. And if grid IJ equals E, return cost. If actually you should check that first, yeah, if you're out of range. If grid IJ yeah. If I is less than 0 or I is greater than or equal to M, or J is less than 0 or J is greater than or equal to N, or grid IJ equals a wall, let's return long dot max value. If we've reached the end, we're done. Otherwise, no. You can either move straight or, yeah, so do it like this. Long, straight, equals cheapest path, I plus DID, J plus DJD. Same direction, cost plus 1, and then you can go right or left. D plus 1, let's go left, D minus 1. D minus 1, mod 4. Cost plus 1,000. Basically the same thing down here. This is left. Oh, no. No, you don't change these. So this is going to be the same I and J. Same I and J. And then return the min of those. Straight, left, right. Maybe. Oh. Still. Stack Overflow. Oh, I'm not keeping track of visited. New pair. New pair. IJ, and then the direction. And you're only moving when you do this one. If let's do this. And the next is actually going to be same direction. Where? Oh. No. Hold on. Let's do it like That's definitely not right. What the heck? This one is a bitch. Oh my gosh. Oh my gosh, dude. I might have a job.
Chris probably thinks I'm a little dumb. That's okay.
I got a job, kinda. I mean, I've had a couple offers, but the first one's kind of lame. They want to pay 17 an hour. In Colorado, minimum wage is 15, so 17 for a software dev. It's like, the heck out of here, dude. But this new offer, I think will be, I think I'll learn more too. It's working with a startup. Okay. Why doesn't this work? Oh, you know what? Oh. Yeah, I don't know why I'm doing that weird stuff. I think this will come out the same though. Yeah. So this is not working. What is heap queue? What is that? Heap queue, heap push, Python. Is that one of his utilities? It might be. No? What is the heap invariant? Why does that work? I'm gonna watch another guy. I'm gonna watch this guy.
All right, we're back.
I'm gonna
for
finish
day
this
16
tonight. I don't care if I have to.
Here we go.
I don't care what I have to do.
Grid. It's a maze. 90-degree turn is the very first move. Okay. What's the lowest score reindeer could possibly get? They can turn 90 degrees, move forward one tile at a time. They never do well. Also rotate, increasing their score. Wow. Okay. This is gonna be a dexterous problem. So let's get the grid. It's gonna be shortest path with like a weird looking adjacency system. So let's see. Find the start and find the end. They're located with S and E. Okay. First, let's just walk through the grid and find these. And then while we're at it, let's also just like clear up the grid a little. once we have the locations, we're fine. The first thing we're going to start at, okay, it starts by facing east, I believe. Yes, it starts facing east. So the directions are going to be, we need to like rewrite our adjacency list in the correct order. So we start facing east. We also need the corridor. The current
So
direction.
he is doing
going to be
Dijkstra's. Where did he get that?
0 and facing east is
Is that
going to
something
be
he just already had? Or did he just shit that out or what?
another grid. It's a maze.
How did he know it was going to be
Anti-Creature's
Dijkstra's?
very first move. Okay. What's the lowest score reindeer could possibly get? They can turn 90 degrees, move forward one tile at a time, but never do a wall. Also rotate, increasing their score. Wow, okay. This is gonna be Dijkstra's problem. So let's get the grid. It's gonna be shortest path with like a weird looking adjacency system.
So he is using Dijkstra's. I was trying to use Dijkstra's. I was doing it wrong.
So let's see. Find the start and find the end. They're located with S and E. Okay. First, let's just walk through the grid and find these. And then while we're at it, let's also just like clear up the grid a little. Once we have the locations, we're fine. The first thing we're going to start at, okay, it starts by facing east, I believe. Yes, it starts facing east. So the directions are going to be, we need to like rewrite our adjacency list in the correct order. So we start facing east. We also need the corridor. The current direction is going to be 0, and facing east is going to be 0 plus 1. Then left is going, we'll say going forwards in this list is rotating clockwise. So then this will be -1, 0, then 0, -1, and then 1, 0. And then the starting location is going to be, okay, so this is going to be our distance, and this is going to be our starting location. Our starting location is going to be this, call this SD instead. And then we'll do, if, let's see, if, the direction we end in does not really matter, I don't think, right? As long as it doesn't matter at the end, then I think we're fine. Yeah. So in that case, what we'll do, if CXCY is equal to EXCY, then we're done. And then the answer, I guess we'll, otherwise, we need an adjacencies function. Shoot, it does like this. Or like, it's nice to have this setup that I have. So what are our options? We can rotate either direction. So we could yield these. If we do one of these, then the cost of that is 1,000. Is that right? 1,000 for rotating? Yes, 1,000 for rotating. Or we can go in the direction that we are given, as long as it doesn't put us into a wall. dx dy, derivative of cd, nx and y, cx plus dx, cy plus dy. If g x and y is not equal to a wall, then we can yield this. That would be nx and y, and the direction doesn't change. Okay, there's our adjacencies. I think this is just fine. I had pre-written a Dijkstra's for just this moment. That's a little bit sad. We're emptying our priority queue. Ooh, that's not great. Why are we emptying it? And how are we getting to CXCYCD? CXCYCD? Yeah, how are we getting to this location? That's not right. Something is not right here. XY direction, right? How am I going from 139 to wait, no, oh, terrible bug. Okay, let's not find this out. There's an answer, let's try it. Rank 190, okay,
Dang,
sick.
dude. I don't want to know part
And
2
then now
yet.
question.
I don't want to know part 2 yet. Dang, he did that in like 5 minutes. He pre-wrote a Dijkstra's. Brother. These guys are on another level, man.
It's Dijkstra's. I knew it. I was trying to do that earlier.
I was doing it wrong. So let me just look at
They're
it.
located with S and E, okay.
Priority queue. Distances.
First, let's just walk through the grid and find these. And then while we're at it, let's also just like clear up the grid a little. Once we have the locations, we're fine. The first thing we're going to start at, okay. It starts by facing east, I believe. Yes, it starts facing east. So the directions are going to be, we need to like rewrite our adjacency list in the correct order. So we start facing east. We also need the curvature. The current direction is going to be 0, and facing east is going to be 0 plus 1. And then left is going, we'll say going forwards in this list is rotating clockwise. So then this would be -1 0, then 0 -1, and then 1 0. And then the starting location is going to be, okay, so this is going to be our distance, and this is going to be our starting location. Our starting location is going to be this, pull this SD instead. And then what we'll do, if, let's see, if the direction we end in does not really matter, I don't think, right? As long as it doesn't matter at the end, then I think we're fine. Yeah. So in that case, what we'll do, if CXCY is equal to EXCY, then we're done. And then the answer, I guess we'll, otherwise, we need an adjacencies function. Shoot, it does like this. Or like, it's nice to have this setup that I have. So what are our options? We can rotate either direction. So we could yield these. If we do one of these, then the cost of that is 1,000. Is that right? 1,000 for rotating? Yes, 1,000 for rotating. Or we can go in the direction that we are given, as long as it doesn't put us into a wall. Dx dy, derivative of cd, nx and y, cx plus dx, cy plus dy. If g x and y is not equal to a wall, then we can get this. That would be nx and y, and the direction doesn't change. Okay, there's our adjacencies.
What the heck?
I think this is just fine. I had pre-written a Dijkstra's for just this moment. That's a little bit sad. We're emptying our priority queue. Ooh, that's not great. Why are we emptying it? And how are we getting to CX, CY, CD? CX, CY, CD? Yeah, how are we getting to this location? That's not right. Something is not right here. X, Y direction, right? How am I going from 139 to... wait, no, CX... oh, terrible bug. Okay, let's not find this out. There...
Position, direction, and we're returning cost and we're returning cost, position, direction. Okay, so start, position, direction, a priority queue, which I assume is based on the cost, and a map. DD. What is DD? What the heck is DD? I don't know. But while the priority queue is not empty, cost and position equals, you got pop from the queue, you got position, direction, and if the position is the end, we're done. Print the cost. And then for cost position in this method that, or this function that you made, if what's distance? Yeah, if our current distance plus that cost is less than the currently recorded distance for that one, then update that distance, and then push to the queue that new distance and that position. Okay. That's so simple. Dijkstra's is actually kind of simple. What the heck? Okay, I can do that. Okay. Alright, we're gonna do it now. We're gonna do it with Dijkstra's. And I'm going to rewrite it again. So I do want a priority queue. What am I going to store in my queue? It's going to be a queue with a pair. We're going to do it just like him. So that's going to be the cost, which is actually, should do it as a long, probably. Let's just do it as an integer. I think it'll be fine. No. It needs to be a long. No. It can be an integer. We'll do it as a long. So you get the cost and a position. New priority queue. And for this, we're going to take in P1 dot get A dot compare to P2 dot get A. So that's our priority queue. We're comparing the distance in there, and the start so this will be position and direction. So this will be position and direction. Start equals new pair. New pair. Position and direction. And this I am using Java 21, so I could just do this, couldn't I? I've been wasting so many keystrokes. I might start trying that out, especially for this crap, dude. So start is that. You have your queue. Oh, and your queue is actually going to be yeah, that's right. Oh, wait. Oh, that's a position and a direction. Position, direction. Goodness gracious. So you're going to have position, direction. So then you have position, direction here, and you're going to say q dot add start oh, that's right. Start There it is. So q.add the distance and the position. And we need a distance matrix. And what do I need to put in there? I think I need to have all the cells. 'Cause we're doing distance to what's an edge? It's a position. It's a position and a direction. Okay. Oh, gosh. Actually, how can I do that? Also, what is DD? We got our start, q.add. Frick. We'll just treat null as infinity. Yeah, we can treat null as infinity. That's fine, I think. Yeah. And what are we mapping? What are we mapping? We are mapping position and direction to along. So we're mapping a pair of pairs where it's a position and a direction to along. So we're mapping a position direction to along, and then we say while not q dot is empty. While the q is not empty, let's get the pop cur equals q dot pop or poll, and let's get the distance and the var cur equals v dot get a. No. That's the distance. Distance and var cur equals v dot get b. And then var current position equals cur dot get a, and if cur pose dot, we'll just say grid, get a, cur pose dot get b equals end, then return distance to dot get what's in there again? The position direction, which is v. Yeah. Okay. And then for D for distance and position in that. So let's see here. So you got 3 of them. You have dude, Python is so compact. Look at these types, man. It's crazy. I think I have. I don't know. Would it be able to imply that? Probably not. So you got trick QS here. So one distance. Let's see here. So you got D1. Position direction. So you got turn left. So you have a turn left and a distance and distance, position, direction. So and this is going to be cur pos dot get a plus di cur.get b. curpause.get cur.get b.
curpause dot get b plus dj cur dot get b
Oh, it's supposed to have a distance first. So moving, you're gonna have 1. So a pair that'll be out here, not in here. Still wrong. So what are we making here? You're making a queue entry, which needs to be a pair of a long and another pair of pairs and a pair of pairs, pair in a direction. cur.getB. There it is. So that's move. That's move. And one will be turn left and turn right. Turn left. Turn right. This is atrocious. Turning left or right is going to be 1,000 cost. And you're not going to add to the direction or anything. Or you're not going to add to the position. You are going to do turning left. You're going to plus 3 mod 4. Turning right, I mean, this is going to be the same. Should be plus 1. Okay, so we have move and we have turn left, turn right. And, okay, so I guess we'll just do them one by one. If dis plus d, if dis plus move.getA is less than distance to dot get or default, what are we getting? the position, which is going to be cur, right? No. Move. Move.get B. If that's the case, then we want to update that distance. We will say distance to dots. When you change the value of a, I thought you had to use set. Is it just push? Oh, it's just put again. You just put. Very well, very well. We're say distance to dot put. Let's see, what is distance to? We're gonna put the position direction to the distance, and the position direction is move. Move dot get B. Distance plus this big ol', oh, just this. Okay. And then put q dot add. What are we adding? Distance to dot get move dot get B. Oh. The distance and move dot what? Huh? Distance to get B and the position direction, which is it move? Yeah. No. I get so lost in this. This is terrible. Q.add. It needs to be a position direction, and then no, it needs to be a distance. A pair. Okay, this is the distance, and this should be the position direction. Eh? What's up? New pair. Oh. Huh? Distance put move dot get B, which is what the heck? Oh my gosh, I'm so lost already. This is really bad and hard to follow. This is so bad. I'm trying to write Python code in Java. I am gonna finish this. I don't care. This is a position direction. And so to this we need to add the distance to and move.getB. Yes. Yeah, that's it. And you basically just want to do the same thing for these other guys. It's really nasty. And turn left. Literally just change that to turn left, and then change this to turn right. Oh my gosh. This seems really bad. 49. Oh, okay. Wait. How's he handling that? Oh. Oh! I missed a part. Oh my gosh. So we want to see if the current yeah, plus the direction. If grid it's not IJ, it's going to be It's gonna be cur position. Dot get a plus di d. Oh shit. Cur dot get b. Cur pause dot get a, or sorry, get b plus dj. Cur dot get b. Wait, which one? Line 50. Oh, okay. What? Why is that distance not assigned? Oh, what? Oh my gosh, this is impossible to read. This is really bad. So if oh wait. Oh, that's right. Cur dot get b. Yeah, get the current direction. While the queue's not empty, get the thing, the distance, the cur, which is a position direction, the current position's here. If we're at the end, return distance 2, get v. Oh, you should do move last. Ah. Oh, we're also starting at the wrong direction. No, we're not.
So pop from the queue. Get the distance in the curve, which is a position and direction. And if we're at the goal, return the distance to that goal. Oh, that's not what I'm doing. No, that is what I'm doing. Yeah. Maybe I'm getting the wrong distance there. Oh, you just print the distance. Yes. Thank you, Neil. And Dykstra. Sweet. Now that you know the best paths look like, you can figure out the best spot to sit. Every non-wall tile S S dot or E is equipped with places to sit along the edges of the tile. While determining which of these tiles would be the best spot to sit depends on a whole bunch of factors. How comfortable the seats are, how far away the bathrooms are, whether there's a pillar blocking your view. The most important factor is whether the tile is on one of the best paths through the maze. If you sit somewhere else, you'd miss all the action. So you'll need to determine which tiles are part of any best path through the maze, including S and E tiles. Oh my gosh! In the first example, there are 45 tiles marked O that are part of at least one of the various best paths through the maze. How the heck am I gonna do this? Oh my gosh. Oh crap. Any best path? Dude. You're killing me. I thought you'd give me a break. Any best path. Oh, crap. How can I get, like, how can I get it from any best path? I think I would need to... Shoot. Oh, crap, dude. Oh my gosh. This one's super autistic. Oh, crap, dude.
my gosh, how am I gonna do this one? I should have followed my gut, dude. I knew I needed to do Dijkstra's. I just wasn't putting the right things in my queue. Yeah, it's position and direction. That's what makes... Yes. It's not just the cells in the grid. The actual graph of the problem includes the direction. That's where I was screwing up earlier. So we're not using this. Or that. Oh. Son of a bitch. Yummy. Yeah, this is not good, brother. This is not how you write Java, by the way. Ideally, you'd want to abstract. Ugh, instead of having all these nested types. Yucky. So how can I get all the best paths? That's a great question. How can I get all the best paths? That's a really good question, man. Is a really good question. How can you get all the best paths? Oh my gosh, dude. I'm gonna think about it for a second. All the best paths. Well, here's what you could do. Here's what you could do. You could go for each cell. If it's a period, there's no like locked out portions, right? Okay. Here's an idea. Here's an idea that's probably not great. I could loop through the entire grid, and for each open cell, each cell that's not a wall, I can find the cheapest path to the end, the cheapest path to the beginning, add those together. So first I can find the cheapest path. If there are any other best paths, they're going to have the same cost. So once I have that, I can loop through every cell in the grid, find the cheapest path to the end, find the cheapest path to the beginning, sum those up. Is that equal to the best path cost? If yes, that cell's part of the... yeah. Okay. It's not going to be fast, but it'll work. Okay, and then what do I need to do? How many tiles? Awesome. Excellent. Part 2. Okay. 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 I don't feel too bad about this now. Just had to think about it. So we'll have the long cheapest cost. Okay, so and then once we have that, we want to return num cells on a cheapest path. That's all you got to do. Pass in the cheapest cost there, and then here's what we're gonna do. I don't have any like globals on your set. No, I do not. We're just gonna use our logic right there. So this will be private long count. Oh, sorry, num cells on a cheapest path, cheapest cost, loop through each cell. Super simple. I is less than m plus I, j equals 0, j is less than n plus j. And if so I can change this char target whoops, actually this one. Just make sure it still works. Excellent. So we're going to loop through here, and if a cell is open, meaning grid ij is equal to a period, this part is a little ridiculous. Not too much, not too bad though. Long distance to start equals cheapest path from ij. Oh. Oh. We'd need to loop through directions right here, I think. For d equals 0, d is less than 4 plus d. So we're going to loop through those directions. target is S. And then we want to find the distance to the end. Distance to the end is going to be the distance to the E. And if distance to start plus distance to end is equal to the cheapest cost, then we want to plus sum and break. Break out of this loop. I think that's it. And then at the end return that sum. I think that's it. And like for the first example, there should be 45. And I feel like this is almost right. It's like I'm missing a turn in there. How about we say if it's less than or equal to? No. Oh, you need to remember to face back east. Oh, yeah. When you get back down to the bottom. I think that's all we're missing. The direction when we get to the end doesn't matter, but the direction when we get back to the start, we need to make sure that we're facing east again. So there's going to be an extra turn possibly, and that makes sense why I'm like short 1,000 on some of these when I look at it like this. Like this. and this might be particular to this case. No? This isn't exact. This is a cheese if it works. Should be 45. Oh, including the ends. Plus 2 then. See if it works for the other one. So it's going to work for this. Does it work for the other sample? 64. It's going to be a cheese if I get it right. I don't think it'll get it right. Because you could be off by a 1,000 by the number of steps. Now here's when you want to start using some dynamic programming probably. Yeah, so I could speed this up with some dynamic programming. And what do you want to map? What are we mapping? We're mapping a position and a direction. It depends on the target too. Position, direction, target, distance. Shit. So we're gonna map a pair of a pair. Oh my gosh. So this will be position, direction. Oh my gosh. Position, direction, target, distance. So I need, let's build it from the inside out. So you need one for the position, direction. So that's the position, direction. This is the position, direction. And you need the target. So it'll be a pair of position, direction, and the target. So that's position, direction, target. And nest that in another freaking pair of that and the distance, which is going to be long. 2, 3, 4, 5. 1, 2, 3, 4, 5. Start map. What? What's your deal, man? It isn't. It is. Uh-oh. What? What is actually wrong? Oh. You don't need this one then. So you have the start map. We're also going to have the end map. Start map and end map. Well, yeah, we could just map them right here. So you get the cheapest. Long dist to start equals start map dot get or default. And what are we passing this? Oh my gosh. This. Oh my goodness. Position, direction, character. And in here you need position, direction. So a position. Well, it's going to be a position, direction. Oh, we don't need two different. We don't need two different maps. Just call it map then. Or this. That's the distance to start. The distance to the end. It's gonna be that. And yeah, that's that. Then you want to put those in there. Oh, crap. Map.put if absent. This whole mamma jamma. This actually isn't gonna make it go faster. I need to do this. I need to do this. Where do I need to do this? How slow is this? Let's see. Like, where are we at? First, let's print out. Like, how slow is this? You could parallelize this too, just brute force parallelize it. Oh gosh. How many rows and columns do we have? Oh, okay. I don't think it should take that long. Oh yeah, it'll take a long time. This will take forever, bro. I can't do that. Let's see. I mean, I have dist, so... And this would be distance to... It'll always be distance to the one that's not target. It'll be so you don't want to do that there. It'll just be like distance to goal. And instead of that, it'll just be dist. So come down here to where we get dist. And dist to goal is going to be map.put if absent. And it won't be IJ. Well, yeah, no, it won't be IJ. Come down here. This will be dist. It'll be target equals S then it's the distance to the end, else it's the distance to start. I think that's what you want to do. Okay. Well, it doesn't seem to have made it faster at all. Which is interesting. It may have made it a little faster. It actually looks like it's getting faster. It is. Okay. It's solving more and more of it. Or am I tripping? It kind of seemed like it was, right? It is. It's solving it faster and faster. Interesting. Will it speed up? I think that's what I need to do though. It seems like it's speeding up sometimes, but then sometimes not. Hmm. And I need to use shit. Well, could I use another get in here maybe? If map dot oh yeah, I think I have another idea. If map dot contains key, all this junk target, right? Then return map dot get that. Oh, whoa, whoa, whoa. Map.put if absent. Are we putting in the map up here? Oh, we're not. Would the reverse cost be the same? Yeah. Why wouldn't that make it faster? Yeah, that's not it. Hmm. Oh, you know what? Yep, that'll fucking do it. I'm not putting the right key in there. I'm such a nub dummy wummy. Let's do this. This will be curpose get A. No, not that one. Do it like this. This will be curpose dot get A, curpose dot get B. That's what it should be. That's what your key should be. There it is. 2. 2 is not the right answer.
Let's see what we get for part 1. Are we still getting the right answer? Yes. 2 is not the right answer, obviously. And I actually... Try it with a sample again, because it's not right, obviously. This one should be 64. 2. Okay, so change this back to change it back to that. 3. What the hell? I feel like I'm right there. It has something to do with the direction at the end. I don't know how we're getting zeros in there. Oh, what are you doing? You could just pass cars. Oh crap. It's not D. Yeah, that'll do it. It's cur.get B. Oh my gosh. Cur.get B. How is that not screwing up the other one though? Cur.get B. Cur.get B.
Okay, that seems more right. Might be the same thing as earlier. No. What if I just do... $132 is not right. Let's see. So, like, let's see. So if I start here, yeah, you need to start. Well, that's why I'm looping through all the directions. That should handle it. Looping through all the directions should handle it. It seemed like a good idea. It seemed like it was going to work. It seemed like it was going to work. So I think whatever I was doing earlier was working. As soon as I started to memorize it, it broke. Get rid of this again. Maybe I'm putting the wrong key in there again. Let's see. Oh, you know what? Why don't I just... leave that part out. Because I feel like we're off by 1 turn or something. Okay, that gives me 64. This should give me 48. 45, I mean. Okay. That seems good. It's not fast. What are we putting in the map? We're not putting anything in the map. We gotta put it in the map up there. We gotta put them in the map up here. Map dot put. I feel like I'm really close. No! Why did that break it? Why does that break it? I don't know, but it sure does. From here to the start is the distance to start. Oh, you know what I need to do? I think that's gonna break it. What about my other solution? Okay. Okay, so it didn't break that. Okay, I have a good feeling about this. Have a good feeling. I have a really good feeling about this. Oh, we weren't putting it in. Shit. Okay. Okay. Two again. Two again. I have no idea. I have no idea what's working. Mhm. What's breaking it? Let's see here. Two. It's that. Why does that break it? Does this break it? Yes. So, does that mean I'm not using the map at all? Yeah, because I'm not putting anything in it. Gosh, dude. Oh, what the heck? That's interesting. It doesn't break the first half. If map dot contains key. I think it's what's interesting to me is that it doesn't break the first half. Just the second half it breaks. the heck? What the hell, bro? Why does it break it? What am I doing wrong here? Map that contains key. An equity grant is a non-cash acquisition. Okay. I'll take it. Okay. Okay, dude. I feel pretty good about this. Why don't you work? Oh my gosh, dude. I could just I could let it brute force. I could just let it run. I don't want to do that. I know I can. I know I can do some dynamic programming here.
missing. But this works, right? But as soon as I add shit to the map, it fucking breaks. Why? Maybe don't add the distance to it? I think you're right. Nope. Keep doing that. Now they're like really big, huh? Now what are we off by? We're like... I don't think it's that number. And then what do you get if you say plus distance right here? What is that? What is that? What does that do? Now they're huge, so you don't want to do that. That's obviously wrong. So you don't want to do that. What if you just do it here? Now you have zeros in there. That's weird. That's not right, obviously. You're kind of all over the place now. Wait a minute, wait a minute, wait a minute. I just want to be done, brother. Oh. Hmm. We should be mapping. Current position, direction. We're like mapping it backwards, basically. Oh, we need to map this to the start. Well,
know what? Yeah, try that out. Instead of mapping character, map to another position. Try mapping to another position instead. So this would be to the start, right? Start.get A. Let's make sure it didn't break our okay, right? Okay. quite, huh? Oh. Hmm. So we're mapping. I should map. Oh, now we have quite a few that are actually equal. Okay, that's gotta be it. I see a bunch that are equal. There's 45. Is it even using the map? I think it's probably using the map now. 64. 66. Damn. It's like slightly off. Maybe just map to if the target is start, then do that. No, that broke it. That fixed it. 64. 66. Supposed to be 64, right? Yes. Damn it. But how fast is it now with the big one? I'm just curious. It is not fast at all. I'm just gonna let it run, dude. I don't even care anymore. I'm just gonna let it freaking run. I'll figure out how to use dynamic programming. 2? Now it's really fucked up. Now it's really fucked up. How the fuck did I fuck it up now? Oh, okay. Alright.
Screw it, dude. I'm just gonna burn up my CPU. I don't care anymore.
I do not care anymore.
My brain's melting.
Alright. I will now watch how they solved part 2. Damn, my Xbox has been on for like 3 days.
XY direction, right? How am I going from 139 to wait, no, oh, terrible bug. Okay, let's not write this up. There's an answer, let's try it. Rank 190, okay, sick. And then now the question is, whether the tiles on one of the best paths through the maze, how many tiles are part of at least one of the best paths through the maze? Okay, so for this, what we're gonna do, so I think we no longer want to break when we're done. What we will instead do is we will finish this operation, and then we'll go through every square in the grid, and it includes the start and the end. Okay, good. And then if the idea is, if there exists a direction. Ooh, this is not actually great. Because the direction matters that we entered this in. How do I want to do this? I'm actually not sure. I was gonna check to see if any adjacency from this tile results in taking a step that is like the goal distance, but I don't think that works. Shoot. I guess, okay, so here's what we can do. We can create a from dictionary, which will have, sure, and then if, whenever we find a new node, with equal or better distance, then we add it to our from. So we know that like the best way to get to this adjacency, well, cur is one of the best ways to get there. And then what we can do is we can start at the end. We can start at the end. I guess what we need to do. So this could be any possible direction.
Okay, I'll figure it out later. See you later.
For each of the possible directions,